Cool trick, Carbon.
Carbon, this is fascinating. Are you auditioning for the circus?
Nah, just proving my adaptability to my friends.
Everyone knows you're among the most versatile atoms.
Yep, there would be no organic chemistry without me.
Not cool, Carbon. Me, nitrogen, and oxygen are all stars of organic chemistry too. Oui.
I'm in complete agreement that carbon, hydrogen, oxygen, and often nitrogen are the primary elements found in living things. But carbon's versatility is at the very heart of the definition of organic chemistry. Organic chemistry is the study of the structure, properties, composition, reactions, and preparation of carbon-containing compounds.
Most of which are found in living things and include moi. And almost all molecules found in living things include me. And I'm in a lot of them too.
All right, fellow atoms, you have made your point.
I'm found in all sorts of compounds, including inanimate gases and minerals, but the molecules found in living, organic things like DNA, carbohydrates, lipids, enzymes, and other proteins all need the versatility afforded by my ability to branch out in 4 directions and make single, double, or triple bonds.
Yes, Carbon. And of course, most of these bonds are polar covalent, which is part of the reason these molecules tend to be asymmetrical and take complex shapes.
I too, as well as nitrogen, can make double bonds. And nitrogen can make triple bonds. You win, dudes! I only have one free valence electron, so I like to keep things simple. Only single bonds for me.
Most atoms have a maximum of 8 valence electrons, but I have only 4, leaving me 4 spots to bond with others. Once I branch off in 4 directions, if one of those bonds is with another carbon atom, she too can branch in 3 additional directions, and so on. I can be part of molecules that form complex branches, chains, even rings.
Yeah, well, me and you can still make simpler organic compounds, Carbon.
That's correct. Hydrogen, although the single bonds carbon makes with you aren't as strong as the double bonds she can make with oxygen and the triple bonds she can make with nitrogen, you are a key component of many organic compounds, including the simplest, the alkanes, like methane and propane.
Alkanes are also known as saturated hydrocarbons.
Yep, and when I double bond with one of my triplet sisters, we can form the basis for another type of hydrocarbon called an alkene.
Heck yeah! And when all 3 of you carbon triplets get together with me and some of my fellow hydros, we can form an alkyne compound. And that is enough bragging for a beat. Let's take a break. Would anyone like a sample from my vineyard?
None for me.
No, thank you, oxygen. But I see you're illustrating the simplest hydrocarbon molecule functional group, the hydroxyl group.
A hydroxyl is also called an OH group. Don't forget, you can't make a hydroxyl without me. Correct. Hydroxyls are found in all alcohols, including ethanol, found in my wine. Alcohols aren't the only thing we're found in, Oxy buddy. We hydroxyls are found in lots of compounds. And don't forget about the most common one, dude. Water. But of course, we make water when one of your positive hydrogen ion brothers bonds to us when we make a negative OH ion. Xenon, remind me, what's a functional group?
Nitrogen. Functional groups are combinations of atoms that form parts of molecules which share similar types of reactions. The alkanes, for example, are all highly flammable. Functional groups also influence solubility. If the functional groups of the solute and the solvent interact well, solubility increases.
Yeah, man, like since sugar and water both contain the hydroxyl group, sugar dissolves in water pretty easily, especially when you heat the water up.
And don't y'all forget about another important functional group, the carboxyl group.
Oui, oui. In a carboxyl group, a carbon atom is double bonded to moi and to an OH group.
Correct. Compounds with a carboxyl functional group are called carboxylic acids.
Xenon, I've heard other atoms talk about forming R groups. How does that differ from a functional group?
The simplest way to explain it, nitrogen, is that R represents the rest of the molecule. Specifically, any organic molecule fragment in which a carbon atom is directly bonded to a functional group. That's me again! Of course, as I was saying, Carbon, when an atom of you is bonded to a functional group on one side and an R group on the other, and that R group is part of an amino acid, it gives the molecule specific characteristics, including size, shape, polarity, and pH.
Carbon, you might as well be queen of the universe. You're one of the world's most important atoms.
Shucks, Nitro, you're sweet. Like these organic fruits I've been balancing on my head. Fruit is full of sugar and other carbohydrates.
Sugars are full of you and your twins, Carbon. That makes you sweet too. Thanks for helping to feed the world. Carbon, my favorite thing about you is that you, like moi, burn organic compounds in combustion reactions. Maybe we can get together later and cause an explosion. Cool! I can help with that. Carbon, can I be your agent? We can take that versatile act of yours, but blow you out of a cannon first. Woohoo! That's one circus act I don't want to miss.
Hey, y'all! If you like what we're doing, help us get sponsors.
It costs you nothing to increase our ratings. Just like, subscribe, ring the notification bell.
Leave our channel some kind comments.
And dudes, tell your buds about us.